3.4 equivalent statements. So more truth tables, and how can we determine if two statements are equivalent using a truth table? So it's like saying 1/2 and 2/4. They mean the same thing, they're equivalent. So how do we kind of put that into a more broad spectrum of how can I make an equivalent sentence with truth tables? So two statements are equivalent, symbolized a double line, double arrow, or 3 lines. If both statements have exactly the same truth value in the answer column of the truth table. If the answer columns are not identical, the statements are not equivalent. Sometimes the words logically equivalent are used in the place of the word equivalent. So what we're talking about is that our final answer, our answer column, they match. So we're saying if the answer columns match, they are equivalent. So because the truth table have the same answers, column 3 for both tables, the statements are equivalent. Therefore, we can write it in this way. Or we can say P and Q or R. We could do the 3 lines and say that it's equivalent as well. So either way, both are correct. Honestly, the 3 lines are easier because to draw a double arrow, I don't know, that's harder for me. Just personal preference. Alright, De Morgan's Law. Remember when we talked about De Morgan's Law back in chapter 2? So I said to kind of remember that we're going to come back to it in chapter 3. So I want to break down De Morgan's Law a little bit in the sense of what we did for our sets. So remember when we did De Morgan's Law, like we distributed the complement? Just as a reminder, remember this is De Morgan's Law as a set. Remember that was De Morgan's Law? So we kind of like, as we said, distributed, so it changes the sign because the complement meant not, and not is a negative. So see, isn't that mean a negative? Doesn't that mean a negative? But it's a negation. So we, as we said, with little quotations, we distribute it. And then you notice all the signs change. So then we have negation P, the and becomes or, negation Q. So that it, and remember, it goes both ways. So we're going to use De Morgan's Law to write an equivalent statement. So write a statement that is logically equivalent to, it is not true that tomatoes are poisonous, or eating peppers cures the common cold. So just like anytime we're trying to write a sentence or use logic or use anything like that, when we're talking about statements, let's bring out our P's, our Q's, our R's if we have it. So our first statement is, it is not true. So before we even get to anything, we're negating the whole sentence. So it is not true. Tomatoes are poisonous, so let's say that's P. We have our connective of or, and then our next kind of object is eating peppers cures the common cold. See how I'm not writing every word, I'm just like kind of I'm not abbreviating it, but I'm keeping it short. I'm not writing eating peppers cures the common cold. No, I'm just eating peppers cure common cold. You know what that means. Be as lazy as you want here, but make sure you do write something for P and Q, so it takes a lot of that room for error out. So we're going to read along the statement and figure out what we have. So first things first, we have it is not true. So before we get to anything, we negated it. And when we do that, we put our parenthesis. So it is not true that tomatoes are poisonous, so that represents P. Or, that was our connective. Eating peppers cures the common cold, that stands for Q. So it's telling us to use De Morgan's Law. That means that's what we have to do. So to use De Morgan's Law, this is what we have. This is what we have. That's what we came out to be. So what we need out of this, we need to create our sentence out of negation P and negation Q. So that's why we wanted to write our P's and Q's out, because now we have to negate those P's and Q's. So to negate P, we would say the tomatoes are not poisonous. We have our connective of and. Now we have to negate Q. So to negate Q, we would say eating peppers does not cure the common cold. So our equivalent statement, so the original statement we started off with was, it is not true that peppers are poisonous or eating peppers can cures the common cold. So an equivalent statement to that, the tomatoes are not poisonous and eating peppers does not cure the common cold. Now if you think about it, they do mean the same thing, because we're saying it is not true that tomatoes are poisonous and peppers cure the common cold. So we're saying none of this is real. We're nodding the whole thing. So instead of saying not before the whole statement, we can not individually. So we can say that tomatoes are not poisonous and eating peppers does not cure the common cold. Alright, determine which statement is logically equivalent. It is not true that the tire is both out of balance and flat. So we're given 4 statements. We need to figure out which one or which ones are equivalent to the statement that we're given. So sometimes it's hard to tell. Because if we start reading, so the original statement, it is not true that the tire is both out of balance and flat. So the statements we're seeing if are equivalent. If the tire is not flat, then the tire is not out of balance. The tire is not out of balance, or the tire is not flat. The tire is not flat, and the tire is not out of balance. If the tire is not out of balance, then the tire is not flat. So that's kind of hard to tell by reading. And it just kind of, to me, it blends together when you start reading it all out. So we're going to use truth tables to determine if something is equal or not. I just want to remind you, for the test, I will be giving you P and Q and R if we have it. I want to show you the sheet that I'm going to attach to the test that you're able to use for scrap paper. So this is what I'm going to give you for the test. It's scrap paper. You're allowed to use this. It has your P's, your Q's, and R's. It has a whole bunch of them. Because on the test, I can't provide you the truth tables on Canvas. I provided like logical answers for you to answer after you do truth tables. So that's why I provided truth tables for you for your scrap paper. Hopefully that all makes sense. If not, just to sum it all up, this is your scrap paper. You're allowed to use it for Chapter 3 tests, because I told you you do not need to memorize P, Q, R. Okay. So the first thing we want to do is take our original statement and determine P, Q, and if we have an R, and see what we have. So we need, it is not true, so we're negating the whole thing. Then we have the tire is both out of balance, so that's our P, the tire is out of balance. We have our connective of and. The tire is flat. So flat means the tire is flat because it says the word both. So we would say the tire is flat. So our statement, if we wanted to write it out, it would be negation, parentheses P, and Q. To determine if something's logically equivalent, we need to figure out what the answer column is for our statement. So our statement, we have negation, parentheses P, we have our connective and Q. So we're going to do parentheses first. So 1, 2, bring home the connective. The last one is the negation, and remember, the connective, that's what we're going to negate to give us 4. So since this is and, remember TT, truth and true, mean true for and. So for P, we're going to write exactly what P is. So TT, FF. We're going to write exactly what Q is. So TF, TF. Now we bring it together with and. So true and true is true. True and false is false. False and true is false. False and false is false. Now we need to negate it. So we just negate this whole column. So opposite of true is false. Opposite of false is true. Opposite of false is true. Opposite of false is true. So this is the answer column we need to compare it with. We're going to compare all of our answer columns to column 4. All right, now we need to bring out each statement for A, B, C, D. So A, we have if the tire is not flat, then the tire is not out of balance. So flat, that represents Q, but it has not flat. So we do negation Q. We have our connective of if then. The tire is not out of balance, so tire is out of balance. That's P, but since we have not, we're going to negate P. So this is an if-then statement. For if-then, the only thing that's false is TF. So we want to write everything that's negation Q. So false, true, false, true. Now we need to do negation P. So false, false, true, true. Now we do our answer column. So F then F is true. True then F is F. F then T is true. And true then true is true. So let's see, do they match? We want to look. Do our answer columns match? They do not. Since they do not match, it is not equivalent. So negation Q, if then negation P, that is not the same. So we move on. All right, so for B. So sentence B is the tire is not out of balance. So the tire is out of balance. That's P. But since we have the word not, we're going to negate it. Our connective is or. The tire is not flat. So flat is Q, so the tire is flat. That's Q. But since we have the negation, we're going to put the little squiggly. All right, let's figure out if this is equivalent or not. So we have negation P or negation Q. So it's or. So only one thing needs to be true for or. All right, so negation P, everything opposite P, we have F, F, T, T. Negation Q, so opposite Q, so F, T, F, T. Now we're going to bring it together with an or. So F or F is F, F or T is T, T or F is T, T or T is T. Let's match it with our answer column. So let's see if it matches. It does match. It's exactly the same. Since it's exactly the same, this is equivalent. I'm getting tongue-tied. We have to keep going because there can be more than one logically equivalent statement. There can be. So we have to keep going and try C and D. So this one, though, it does work. Let's go on to C. So C is the tire is not flat. So the tire is flat. That's Q. But since there's a little not, we have to put the squiggly. We have our connective of and. The tire is not out of balance. So the tire is out of balance. That represents P. But since we have the word not, we put a little squiggly. So let's go ahead and fill out our truth table. We have negation Q and negation P. So negation Q, opposite Q. Negation P, so opposite P. And we're going to bring it together with and, so it has to be true, true. So F and F is F, T and F is F and T is F, T and T is T. So let's compare our answer columns. Since we know B is the same, since B is the same as the answer column, we can just compare it to B real quick. So let's compare it to B. It is not the same, so this is not the same. So we keep going on. All right, our last one, D. So sentence D, if the tire is not out of balance, then the tire is not flat. So out of balance, that was P, so the tire is out of balance, so that's P. But we have the word not. So since we have the word not, we need to put the little squiggly. We have our connective of if them. Then we have the tire is not flat. So the tire is flat. That was Q, but we have the word not, so that's a little squiggly. So we have negation P, if then, negation Q. All right, so opposite P. Sorry, wrong column. Opposite Q. Now we bring it together with if then. So remember, for if then, the only thing that's false is TF. So we have false, false, that is true. False, true is true. True, false is false. True, true is true. So if we compare answer columns, it is not the same. It is not the same. So the only one that is the same is B. So how do we say our answer? Because there's always a fancy way to write our answer. So our original statement was negation P and Q. That was our original statement, is equivalent to our statement negation P or negation Q. There is something there that you're seeing. There is something. It doesn't necessarily matter that it's not a law, but it is true. It is always going to be true there. All right, the conditional statement written as a disjunction. So sometimes the statement we have is just not going to work for us, so we need to write it in a different way. So the conditional statement written as a disjunction, if we have P if then Q, it's the same thing as negation P or Q. To change a conditional statement into a disjunction, negate the antecedent, change the conditional symbol to a disjunction symbol, and keep the consequent the same. That's all this means. That's all we said. That's what we're doing. In a sentence, that's what we're doing. So example 4, rewriting a disjunction as a conditional statement. Write a conditional statement that is logically equivalent to the cows are in the pasture or the horses are not in the barn. Just as a reminder, you remember the antecedent? That's the first part of the sentence. That's the P. And to negate it, remember that just means to negate the first part. So that means that. We change the conditional. So the conditional is here, and we change it to a disjunction symbol. That means or. And we keep the consequent. So remember, the consequent is the second part. That's this, the Q. So we keep it the same. Let's break down our P's, Q's, and R's. So our first, subject is the cows are in the pasture. So P is, I'm just going to put cows. If I could refer back to this, I know the cows, it comes from the part, the cows are in the pasture. We have our connective of or. The horses are not in the barn. So that's our Q is horses in barn. So if we wrote this as a statement, we have the cows are in the pasture, P, our connective of or. The horses are not in the barn, so Q, but since we have the word not, we put the little squiggly. So what we're given this part right here. So we want to go to P if then Q. So let's write this sentence as, oh, I forgot to tell you something. So we're going to write this sentence in symbols now. So the cows are in the pasture, that's P, because that represents cows. We have our connective of or. The horses are in the barn, so that's Q, but since we have that little knot, we have to put a squiggly. So we have to match a left side with one of our other sides. So we have, let me erase this because you can't see it. There we go. So if we look up here, that's not the same, right? That's not the same. But if we look down here, isn't that the same? It is. That is the same. So to get an equivalent statement, we need to do negation P if then Q. So we need to now write this sentence. So to negate, so we need to negate the whole thing. So to negate the whole thing, we can say it is false, it is not true. I'm going to say it is not true. Comma, because of the parentheses. We have P, the cows are in the pasture. We have our connective of that arrow. So the arrow, we have if then. We have Q. Nope. That's fine, I'll just do a different color for Q. And then we have Q, which is the horses are in the barn. All right, let's do the same thing. Write a statement that is equivalent. It is false that if you hang a picture, then it will be crooked. So we have our P, if you hang a picture. So hang picture. We have our connective of if then. We have our Q, it will be crooked. So we have it is false, so negation. If you hang the picture, so P, then it will be crooked. So a equivalent statement to that would be P and negation Q. So let's go ahead and write this as a sentence. We have P is if you hang the picture. So it's not if now because we have the and. So is you hang the picture. So you hang the picture. We have our connective of and. We have to negate Q. So opposite Q is it will not be crooked. So the picture will not be crooked because what does it stand for? It is the picture. All right, before we get on to the last example, I kind of want to talk about 3.4. I don't heavily test on it. So variations of the conditional statement. The variations of conditional statements are the converse of the conditional statement, the inverse of the conditional statement, and the contrapositive of a conditional statement. So a conditional statement, that's if P then Q. A converse is Q if then P, so it's just the opposite. Inverse is negation P if then negation Q, and the contrapositive is negation Q if then negation P. I don't know if any of you are planning to be lawyers, but oh my gosh, chapter 3 is where it's at for lawyers. This will be on your LSATs and your bar exam. If you've seen Legally Blonde, when she's studying, it's a great movie by the way, when she's studying for her LSATs, when they're reading those sentences, like those weird sentences that seem just like they run on and make no sense, this is what they're doing. Cool, right? Alright, so the converse, inverse, and contrapositive. For the conditional statement, if the painting is by Andy Warhol, then the painting is valuable. We're going to write the converse, inverse, and contrapositive of that statement. So, of course, we need to know what is this statement. So our first is the painting is by Andy Warhol. I'm going to say A.W. I don't want to write his name out. Andy Warhol is the Campbell Soup dude. Those paintings. Pop art. Our connective is if then. And then our next is the painting is valuable. So that's our P. Our Q. Alright, so to write this as our statement in symbols, we have P, if then, Q. No negations there. So let's go ahead and write our converse. So the converse is Q if then P. So let's write that Q if then P. So Q, the painting is valuable. We have our connective if then. So we have if then. We have P, the painting is by Andy Warhol. Alrighty, B. B is telling us to write the inverse. So the inverse is negation P if then negation Q. So let's negate P. So to negate P, we would say the painting is not by Andy Warhol. Now don't forget, we have our connective, so if. So if the painting is not by Andy Warhol, then we have to negate Q, so the painting is not valuable. Alright, now we have to write our contrapositive. So our contrapositive, we have negation Q, if then negation P. So let's negate Q, the painting is not valuable, then the painting is not by Andy Warhol. So if negation Q, the painting is not valuable, opposite P, the painting is not by Andy Warhol.